Hi everyone. So thanks for coming today. Thanks for bringing your smiling faces into this big talk hall, hanging out while we talk about this. As Brent said, I'm Adam Perry. My Twitter handle and GitHub info are on the bottom there if you decide you want to come pester me about how terrible I am or how I'm ruining everything in the world or how awesome this is. I'm happy to talk about all that. More happy to talk about the latter, but so what does this mean, practical confidence? I didn't spend a lot of time thinking about the title, I will confess. So let's try to talk more constructively about some of these things that we think about when we're building software, right? There's a few things that we all care about. And I think the bottom line for most teams and most developers, we want to ship like real code, right? And that code has initial development that we usually want to go fast. We all like JavaScript. We like iterating, tight turnaround, seeing our changes immediately. But it also has like a longer life once it's started to find a market, and it has some maintenance needs and some bug fixes that need to happen. One thing that I think is kind of related to productivity is like I have to hit deploy at some point, right? I have to, at some time during the cycle of building features, decide that I'm going to ship. I have to be confident that this is going to make it into the hands of customers and solve their need. But I also have to be confident that I'm not going to get paged, that I'm not going to be spending many, many hours debugging code that's kind of difficult to follow. And I think another thing that's closely related, at least in terms of static typing, is that I care a lot about the cognitive cost of the tools that I use. We're humans. We're pretty mistake prone. We have very limited brains despite all this really cool stuff we build. But we use abstractions and tools and process for managing the complexity, right? So I think this is like kind of the framework that I would propose we all think about when we're talking about these technologies and evaluating them. And let's also talk about kind of the current state of quality in software. Most teams building products these days have some combination of quality practices, right? And I guess if you wanted to be really broad, you could define this as going all the way from like, I clicked the button and it showed up, to I wrote a mathematical proof that the airplane won't crash. And most of us are in the middle, right? We have linting and code review and tests and CI. Maybe not all of these, maybe some more things than these. We might apply them to larger, smaller percentages of our code base. But especially in JavaScript, we, as a result of all of the fatigue that Kevin talked about earlier, also have kind of this nice opportunity to pick really granular trade-offs for our process, right? Like we all have the opportunity to kind of like build our own compiler and build tool chain these days. We can assemble tools together to fulfill like purpose-built needs. And that's where I think kind of like Flow fits in with that quality model, right? So type checking in general, Flow is just one example of this, but type checking in general is getting more popular. TypeScript is definitely taking off. Flow definitely seems to be getting adoption. There are a bunch of compiled to JavaScript static language options available. There's a whole lot of flexibility. But some of the things that they have in common are that they let us kind of sort of prove things about our code before we ever execute tests or ever deploy to production. And that can be very useful for a number of reasons. So I propose that we think about this as kind of like types or tests, right? They're a different kind of test. They specify a different kind of contract. It's often like a structural contract versus like the behavioral contract that like a unit test might talk about. They're often easier to write than unit tests because they touch such a small portion of the code. And they often aren't as sophisticated about the kind of behavior they can specify. Although I think, especially using some of the more fun features I'll talk about in a second, that you might actually, if you haven't worked with this type of tool before, be surprised about how much you can like statically verify about your code without much effort. Some other ways I think it's useful to talk about these technologies is that you can take some core API, and I have some examples I'd like to show in a bit, in your application, some common abstraction that's used hundreds or thousands of times, and type that, and it's like writing tests for everyone who calls into your API. It's like tests for your call sites. Another way you might look at it for your own developer workflow is like pair programming with like me or someone really pedantic and nitpicky, right? And sometimes that can be a little annoying, but if you get a good workflow going together, they can often help you really improve the quality of what you're building. I also think it's really important to talk about the fact that, like all engineering trade-offs, it's not free. I don't propose that every single one of you go and commit a flow config tomorrow to your repo. I don't think it's right for all projects. I don't think it's right for all teams. But I do think it offers a lot. And we should talk about some of the reasons why you might be skeptical before we dive into what I think are all the awesome things about it. So broadly, this life cycle where we're developing initial features and then we have this like maintenance mode that happens later, right? Or not maintenance mode. It's not like a switch that flips, but we spend more time on maintenance later. You can think about something like static types, or test-driven development is this way as well, I think. If you put in more investment up front, you can reap compound interest in the long term about the quality of your software, right? You'd bake fewer mistakes in the early days when everything comes to depend on it later. But we should be specific about the costs that we pay in that early phase. First and foremost, you're in JavaScript land. You don't get a type checker for free, so you have to configure it. You have to pick it. You have to integrate it with your build process and continuous integration. You also occasionally, and I think like Flow and modern tools do some pretty cool things to minimize this, but you have to add type annotations to your code, right? It can't automatically figure out everything everywhere, right? Occasionally, the type checker errors won't be confusing. You'll know something is wrong, but it takes a little bit of practice to always know exactly what that is. And you also, I think, can be kind of constrained. And sometimes this is uncomfortable, and sometimes it's a little bit of a downside. I think other times being forced to have like a statically verifiable API contract reduces the amount of cleverness that people put in their code. And a lot of us have had great, clever libraries we've used. We've also had cleverness bite us, I think, after working for any amount of time. And so, it's always a trade-off. Sometimes that's good. Sometimes the constraint is not so good. And of course, like everything in JavaScript, tools change, and they get more or less complex, and you have to adapt to that, and you have to be willing to commit time to, keep up to date to some extent, right? Because this is a fast-moving ecosystem. And Flow is definitely more stable than it has been in the past, but it's still no different. There are a few downsides or costs to this type of quality process that I've heard a number of times, and I just kind of want to spend a second pushing back on those. I've heard you have to spend a lot more time thinking about your types. And I know this is a little sardonic, but if you weren't thinking about the types of your variables before, you probably have a lot of bugs, right? Like we've all had some moment where we've had to think through what was happening in our program to get to the place where it was now and find out what that type is. Type annotations, and this is a pretty common criticism, make code harder to read, and they obfuscate the control flow and the logic, and that can definitely be true. I think that it can be mitigated to some extent by the tools you choose. And I also think that when it's like below a certain threshold, I at least, and many people I've spoken to, find it useful for providing context, right? And so when we're talking about this cost, this like compound interest investment, these trade-offs, a couple of questions I think we should probably all ask is, is this initial cost we're paying cheap enough to justify what we expect to get out of it? I think there's a lot of things that tools can do to improve ergonomics, and I think Flow's made a lot of good decisions there to make that answer yes for a lot of projects. I also think we have to ask, is the type system that I want to like do this checking with or do this checking against, is it expressive enough? Am I going to end up writing, I hate to pick on Java here, but like, am I going to write like a factory builder and pattern bean delegate, right? Like, do I need extra indirection, complexity, and obfuscation in order to satisfy the type system? And again, I think Flow and some more modern tools have done a pretty good job of minimizing that, and I'll show you some features of why I think that's the case. So let's talk about some of these specific niceties, right? For one thing, Flow is JavaScript semantically. It doesn't produce runtime code unless you like decide to use a runtime validation library for it. So the type annotations are stripped, but they don't actually leave anything behind. If you strip the Flow type annotations as like the only Babel preset, I'm pretty sure you'd end up with like a sane-looking source file in most cases. The software itself is very focused on immersiveness and performance, especially when it's like integrated with your editor. That pair programming type feedback is like very fast and responsive, just like Christoph talked about Jest's watch mode, getting that instant feedback, and this fulfills a very similar role. It's also got a type system that's designed to express like idiomatic JavaScript. And these two last features, structural nominal typing and type inference, I'll talk about in more detail, but I think they're very important for ergonomics. One thing that I think anyone who's like nodding at all or thinking like, maybe this random guy from Arizona has a point, should do is hop on Flow's website. There's some pretty good docs. They have a playground that will run in your browser. I'm sure there's some some very strange things happening to make that work, but it's very nice to try a little snippet of code, add some types, get a feel for it. It's especially useful if you think you've got some kind of weird inference thing happening. You can go and paste it in there and massage it around a little. Okay, so enough about philosophy and trade-offs and rambling. Let's talk about types, right? They specify structure. They specify, to some extent, behavior, the same way that unit tests can specify behavior and like transitively can specify structure. And I think the like overarching theme that I would like to introduce all these features with is that you want to think about this as like constraining your program's state to like predictable and valid states, right? You don't want to end up chasing something for hours because some code like thousands of lines away didn't do what you expected. And you also want that to come easily. So I mentioned type inference earlier. Let's look at a quick example of some uninferred type declarations. This is Java again. I'm picking on, I actually kind of like Java sometimes, but in Java, you have to specify the types of every variable declaration. It'll infer if you have dot method calls, and Java might eventually get type inference in a future version, but this gets especially complex if you have to say have a linked list of array lists of hash maps of some class, and that's like a whole line before you've even written the name of your variable or written anything that it does, and that can make it very difficult to read. If we look at, this is a trivial example because it's a slide, but this definitely gets worse with time. You have to work to manage it. With Flow, it's inferred within function bodies and within non-exported functions. This last line, I call this kind of like a type assertion when I'm talking about it. I don't know that there's an actual name for it, but it's basically saying, hey, Flow, make sure that this type matches what you've inferred, right? If we didn't include this line, Flow would still infer this correctly. We have a number, we've pushed it onto an array, we have an array of numbers. Good job, Flow. It does this in much more complex cases as well. This is obviously a trivial example. And if we tell it, hey, can you make sure this is an array of strings, it'll say, oh, what are you crazy? It's it's an array of strings, you can't push a number on it, right? So you get a good error out of that. There's no hidden magic. When you type this into the playground, you should get an equivalent result unless they've deployed a new version that breaks this in the last couple days. So in summary, with Flow, generally, you only have to write these verbose type declarations anywhere where you specifically want to define some type, where you want to export a function, or you want to export that type, right? Like a class or some structure. And occasionally, as a caveat, when you're doing something kind of hairy and the inference isn't smart enough and you need to create what's called a fixed point in the middle of your function so that Flow can kind of figure it out. This is an example of a function's type signature. So let's also talk about structural and nominal types. I apologize for moving kind of quickly. There's a lot that's great to talk about with Flow, so I'm just going to keep on rolling. Structural typing is kind of similar to duck typing, but semi-specified, I guess. It's like the shape, right? It's the structure of some piece of data, and it checks whether it satisfies that shape, right? Nominal typing is based on the name of a type. You say, here's some class, foo, and that class has a bunch of behavior attached to it and it has a name, and the contract that I want you to check for me is that that name is matched, not just that it's shaped the same way. And I'll show you an example of what I mean and why it's important in just a second here. So in Flow, one way to specify a structural type is with the interface keyword that you can see. So we say this interface is an object that has a property called bar, and that property should have a string value at it. We have a function that wants to take an interface like this. We can pass that function an object literal. Flow will type check this happily. No type errors found. If we try to do the same thing with a class, despite having the same shape, right, it will not accept it, right? So this is kind of that shape versus name distinction. The reason why this is really awesome is because your type system can't understand everything about your program, right? If we have a string and it's a property on some class and that string always has some maximum length, there are programming languages which allow you to teach your computer about that maximum length and then to assume that everywhere, but that's a lot of work, and we're not there yet in terms of the ergonomics and the community, at least for most software these days, I think. But what you can do is, a class is like some data and it's some behavior attached to it. And you can teach the type system about that behavior by attaching that behavior to a name. And you can say, I want this behavior anywhere I've said this name. So you can write functions that expect that max length of string quite happily. It will reject a structural type like this, right? And here this string would be truncated, and then we would be able to work with that string in wants baz however we wanted. The next thing that I think makes Flow very useful for JavaScript projects is that undefined is not a function is not quite literally the worst, but it's like the worst. And maybe types allow you to teach your computer about what's going to be null and undefined and what's not going to be null or undefined, what's guaranteed to be there, right? So here, hopefully everyone has a screen close enough to get some sense of what I'm talking about. Apologize if I've made this too small. We have an interface, Raffle. It has an optional field, what. These are terrible names. We have a function, Raffle Stomp, which returns a Raffle. Again, I apologize. And so then if we call Raffle Stomp, we get that object back out, even though this field is undefined, and we try to access the length property on this potentially maybe string. Flow will yell at us, right? Oh, no, you can't do that. If we introduce a check, Flow's totally fine, right? We've proven to Flow, hey, by the time I get inside this conditional expression, I'm okay. I know this is a string, it's here. And you'll note that there's some type definitions up here, but when you actually use this API down at the bottom, you don't have to do anything beyond what normal, reasonably written JavaScript would look like. And I think that's really important for introducing this into a day-to-day workflow. Union types, I think, are another really useful thing that Flow does for code that would normally be dynamic, but that you would never write in Java, right? Or C# or C++, or pick on any kind of static type system you learned in school or are maybe frustrated by that led you to come to JavaScript. So you can define a union type, like we have this primitives only type. And it can be a string or a number or null. Maybe in one case we assign a name. Maybe in another case we assign an age. This is terrible software I'm describing, but you understand what I'm saying. And this becomes especially useful when we add it together with some other features. So these are kind of a few core concepts. I'm going to jump into some more complex examples momentarily. If you're not familiar with any of this, I'm going to try and provide a little context, but the Flow docs are actually quite good these days, and I'd recommend, checking those out. I'm also, around and happy to talk at length about this, obviously. So a common abstraction lots of applications have, front end, back end, whatever, is we have some cache. We want to run a function if we don't already have the value, but if we already have the value, don't run the function, right? So it's a cacher. It's, again, a bad name. Apologize. In this case, though, we define a class just like we might otherwise, but this has what are called generic type variables. Ooh, it's just placeholders, right? And that lets us use these names elsewhere in our definition of the class. We can also say, hey, this cacher has some function that we want to call when we don't already have the value for some key, right? So we have keys, we get values, we want some way to from a key get a value because we might not already have that key already. So k is an input to this function, and it returns either the type or an asynchronous promise for that type. So this is a nice use of the whole union type concept. And then when we actually go to write the definition for the cache behavior, we can continue using these type variables. So we say for any key, it doesn't matter what kind, as long as we can check it for equality, right? We can get a promise for its result. And we can, write the whole body of that function without any type syntax. That's really nice. That's the inference at play, right? And then when we go to use this function in our code, the consumers of our API don't necessarily have to write any type definitions at all to get free checking to make sure they're using this accurately. They give it a function closure and says, well, what I want back from this cache is to JSON escape any string you give me. And so that creates a cacher from strings to strings. We can add a type assertion here if we want to have a talk slide. In practice, you probably would never do this. And this type checks successfully. And I think this is a good example, in my opinion, of this kind of O of n to O of 1 testing philosophy at work, right? This is the kind of code you would write once, use it a lot, make sure it all works, and then reuse it everywhere you could, right? And so if you need to refactor it, you don't necessarily know what you're going to break. You don't necessarily know that everyone who's using it is using it correctly. And by having a tool that can automatically tell you those things, like with near instantaneity, you can get a lot of value out of that, especially if you start like an incremental adoption process with this sort of core API. Here's another example. This is actually adapted from Flow's docs. They go into a lot more detail about how this works and why, et cetera. But we have this type. It can be, I think, probably most people have at some point called some API that returned a JSON object with like a success key, and that was either true or false, and then the rest of the object was totally different depending on whether it was successful or not. And Flow can make sure that you're using these API results correctly. You can say, hey, if success is true, I have a data field, and it's there's some data here. If success is false, I have an error field, right? And we can return one of these API responses. If we try to directly access that data field without checking for success, Flow's going to remind us, you're about to get an undefined error, right? And we can see the same if we try to handle it as if it's an error, if we just expect it's an error. And Flow is like totally happy if we write this exact syntax just as we would normally when sanely interacting with this API in plain JavaScript. Check for success. Hey, it's successful. I have a data property available. I'll go and use that. If it's an error, use the error property. And this is that whole concept of type refinement, right? Execution flows into one branch of the statement where Flow can prove that we're using it correctly, and we're all good to go. And you can do this at like multiple tiers all the way down. And I think that this particular example, I didn't come up with this example, the Flow folks did. But I think it's a really excellent example of why this is useful for like day-to-day work in JavaScript, because it's really aimed at like what you're already doing as best practices, just checked by your computer as like a helpful buddy. So those are like the high-level kind of examples and type system features I wanted to show you all about why I think this is like more ergonomic than what you might be used to with static type systems. I think there's like some more kind of practical kitchen sink type things I'd like to share with you. So Flow has this optional typing notion. Not everything has to be typed. You can specify what's called an any type, A-N-Y, and that basically says trust me, right, to the type checker. This is the trust me type. It's really tempting, especially when you're working in a large code base doing incremental adoption work for this, to just put that everywhere, right? And that's like honestly fine for most projects because you're trying to add value, not get sucked into a big time sink, right? But I think there's one tweak I would suggest for anyone here who wants to try adding it to their code base, and that's to use something greppable, right? Presumably, most of us use git grep. I use rip grep these days because I'm into Rust and I love it. There's Silver Searcher, AG. They're really good at finding unique strings in giant blobs of text. And you want to provide yourself a unique string so that you know when you've said, I'm going to skip this for now and worry about it later, right? If you're going to create debt for yourself in this tool you're adopting, make it easy to go back and clean up. It's configurable, so by default, Flow has a suppression comment of flow fix me specified, but you can also specify a suppression type, and here's examples of both. This option on the bottom goes in a Flow config. There are tons of configuration options. Don't use most of them to start. Use them when you need them. So if you specify the suppression option, Flow will just say, oh yeah, I gotcha. Length is there, no worries. And if you specify the suppression type, then Flow will continue to trust you for your uses of that variable, right? And then there are two more kitchen sinky kind of things. And one is Flow typed. So it's this repository on GitHub. It's, I should step back a second, I apologize. So NPM is a thing, and not many people in NPM are using Flow compared to people using it in their applications, right? Lots of people are using TypeScript or plain JavaScript or whatever. And if you want Flow to know about the types in the libraries you use, you can either let it just infer all of it, which is like surprisingly decent at for lots of smaller libraries, or you can give it some like library type definition. Flow typed is like a community repository of these. They're maintained by, people like you and me who are interested in making some better software and helping each other do it. They're also really good examples, I think. If you use an API in some library and you don't know how you would express the type for that, chances are someone has thought about this, and they're a decent chance that there might be a definition in flow type, so you can go check that out. They also have a command line tool so you can import it into your project. As with anything, I would exercise caution when automatically committing code, right? And finally, and I think this is like, I wish I had more time to talk about this because it's really, really fantastic. At ReactConf, there was a lightning talk about nuclide and flow integration. I use VS Code with flow integration, and it has a lot of those same features, but it turns out once you have static types for most of your code, you can get like phenomenal autocomplete, like way better than what you would get just based on symbols, right? And you can also get jump to definition because you reliably know where that's defined, right? You can, jump around modules. You can navigate your code base with command click all the way around. And a lot of the time that works without something like flow, but my experience and the experience of many people has been that flow adds a lot of reliability and predictability to that process to help you understand your existing code base. And I think that this is also one of the ways where we can kind of minimize the cognitive cost of introducing a new tool. Not that this makes it easier to use the tool in the first place, but it kind of makes up for something, like when the tool adds work over here, you can make something else easier by having done that other work, right? And so I think that definitely sweetens the deal on those trade-offs. So there are docs on Flow's website for how to integrate with an editor if you decide to pick it up and try it out on your project. So that's most of the content. I kind of wanted to summarize a bit because I know I went pretty fast and talked about a lot of different things. So I think I would recommend trying out Flow or trying out TypeScript, or Cheng is about to come up. Try out Reason, seems pretty cool too. Static types are rad, I guess you might say. You can definitely incrementally adopt it, but you should do the work to do it well. Plan ahead, think about what the important bits of your code base are if you want to start having these guarantees. And think about strategies for making it easy to clean up after yourself and to keep your coworkers happy with you. I would also say that these type system features that I described and kind of briefly skimmed over some examples of, there's a lot more depth there. I didn't talk about like class inheritance at all, and there's a whole amount of power you have in talking about different classes you can accept. The Flow docs have information on all of that. I would recommend that even if you don't try Flow, it might be useful to see what it does and to kind of change your frame of reference about how you read and write code in terms of what a valid value is for your variables and function return types. And we are at a React conference, so I think I'd be remiss if I didn't say that you can do this all with components. In the interest of simplicity and time, I showed you examples of just some like straight line JavaScript code. But Flow is an open source project largely committed to by Facebook, and they care a lot about React. And Flow has good support for state and props, and React has Flow type defs, as does React Native, and lots of libraries in those ecosystems do. So I definitely think that it's worth checking out how those work together. I just want to thank you all for coming out today, and thank the organizers of this and sponsors of this conference, and hope you guys enjoy. I'll be around if you want to chat. Thanks.